over. First, let's touch upon the Intel RealSense Challenge 2014. This is a $1 million contest based on the Intel RealSense SDK and the camera technology. This is for the developers across the globe, spanning to 25 plus countries, and the total cash prize is about $1 million. The highest cash prize for an individual category or application is $25,000 in each category, and a super grand prize of another $25,000. There are various other prizes for the same, and there are 5 categories to develop on. Let's talk about the innovation categories. First, it is gaming and play, which is pretty much simple. It demonstrates the best use of game and gaming or playing around with a PC using interactions, voice, gestures. Next is immersive collaboration and creation, which refers to content creation as well as collaboration between tools or between concepts. Interact naturally, which is as simple as interaction concepts with the PC and the world. Learning and edutainment is simple touching the most common learning methodologies, and edutainment, which is a true mix of education as well as entertainment. Last but not the least, open innovation. As we trust the fact that developers can do more with these technology, so we have left the open innovation category, where if the idea that you're proposing does not fit in the 4 categories, you can categorize it as open innovation. Innovate on top of our application categories, and we are sure you'll come up with the next big thing in the RealSense or the gesture technology. So what are the timelines? This contest is basically divided into 2 tracks, the Pioneer track and the Ambassador track. The Pioneer track is what will touch upon all the open developers, all the developers who have not been part of the Intel Perceptual contest or the RealSense technology challenge in the past. The ideation phase is on from now until 1st of October. You have to register and submit your ideas. From 2nd October until 10th November, we'll select ideas, and 1,000 best ideas that get selected in the Pioneer track will be advanced to the development phase, which starts from 14th November on to 20th January. The Ambassador track essentially is an invite-only track for people who have successfully in past submitted a prototype, demo, or application. 300 ideas from this section will be selected separately, which do not count in the 1,000, and they have a little longish development phase, because there is sizably small number of ideas to be judged from. So the next step would be to go to RealSense appchallenge.intel.com and register and submit your idea. With this, I will hand over the podium to Shweta to talk about the RealSense SDK.
Thanks, Deepesh, for the wonderful introduction. Today, my session, I'm going to dig on the RealSense SDK and how you developers can take advantage of the RealSense SDK for Windows. We are in beta right now. So if you look at the interface of the computing device and how they've evolved in the past 30 years, right? So earlier we had the DOS operating system, where the primary interface was the keyboard and the mouse. And later on, we had a lot of innovations happening with the GUI. Microsoft, Apple, Linux did a lot of innovations on the GUI. But nothing has done with the interaction that you do with the device. We introduced some joystick and light pen. Other than that, nothing much. But in the last 5 years, we had the touch-enabled device, where it was natural and intuitive for the user to automatically play with the devices. So the next question is, what comes next? So we at Intel envision that we have a new kind of interface for you to work with the devices, which will let you fluently shift between the keyboard or the mouse, a trackpad or touch screen, Most of the devices will be gesture-enabled or facial recognition or speech-enabled devices, which help you developer to access these applications or innovate more on the existing devices. Keep in mind, we're not trying to replace the existing interfaces that you have. We're trying to augment the existing whatever is already there in the industry with new kind of devices. Also, we are trying to add the brain to your computer so that it can perceive what is happening around you and who's interacting with it. How does it want to interact? Let's say you come and sit in front of the system, and it should recognize that you are sitting in front of the computer, and all your preferences should automatically get logged in. Or let's say you give a command to the computer, it should recognize that this is the command that you are giving it and what is the interaction that it has to do. Or it can understand your emotions. Let's say you are in a happy mode, and it probably can switch few songs based on the mood of a person, or play a different set of songs if you're in a different kind of mode. So these are the ideas that you can develop based on these kind of technology. So what is Intel RealSense SDK? So how do you achieve that? So you can achieve that using Intel RealSense SDK. Intel RealSense SDK is a free tool and list of APIs which help you to build natural user interface. We just launched the beta a couple of months back, and we have opened up the challenge for you developers. This SDK, the APIs, and it's very easily to access and develop applications, and it's also open and extensible for experts. Let's say, and as you understand, actually building applications using natural user interface is not so easy. So it's very using this RealSense SDK, you developers can easily build applications which take advantage of the gestures or the facial recognition or speech technology. Currently, we have support for Windows 8.1, the desktop, and the Android support is coming up shortly. And we also we want to reach out to a large number of customer base to help you write applications which are enabled for RealSense technology. So let's say you're looking at applications in Apple Store or Windows Store or Google Store. There are a bunch of applications there, millions and millions of applications. So how do you make your application stand out on the crowd? What is the differentiating factor that you add to your application? We believe that if your application is enabled using RealSense technology, then that application will delight your customers, and in turn you can sell your application much better than what it is currently. And also, we have understood the developer ecosystem well, and we are trying to work with the already supported languages, the standard supported like C++, Java, and I'll talk about it in the further few slides, and the existing frameworks and the game engines that you are already familiar with. So how does it work? You might ask me, how does it work? So to start off with, we have the Intel RealSense camera for tablets and for AIOs and desktops coming up. We are already working with a couple of OEM vendors, and last week in our Intel Developer Forum, which displays few OEM machines, especially the Dell Venue 8, which has the Intel RealSense camera embedded on it. We are expecting that all the OEMs will have the RealSense camera, 3D camera, in the bezel of their tablets or AIO or laptops. The 3D cameras are very thin. It's about 3.88 millimeters thin, and it's about 10.8 mm wide. So it can easily sit in the bezel of the computer. Keep in mind, this is the first 3D camera that we are, it's the smallest 3D camera that is out in the market. It works well with indoor and outdoor lighting conditions. It can capture about 60 frames per second, and it supports Intel Core and Atom-based processors. Currently, we have support for Windows, and Android is coming up probably end of this year. So you might ask me, what are the different modules that the RealSense SDK supports? So there are a couple of modules in there: hand, face, speech, and environment. You can use these modules as a standalone, being that your application can only have gesture enabled, or you can use it as a combination of a couple of modules, or all of them. For say, the application can do face recognition and hand gestures. So let's understand each of these capabilities in in deeper level. So looking at the hand modules, what does it do? It does a hand and finger tracking. It can also do a gesture recognition. Our 3D camera is so capable that it can do a 22-point hand and finger recognition. Let's say you keep your hand in front of the camera, it can find out all the joints that are, all the bone joints that are there in your hand, and it recognizes the gesture that you're doing. So by this you probably can understand how much accuracy you can get by having such a fine granularity of the camera resolution and capturing the data. By default, we support about 9 mid-air gestures. Some of the gestures would be thumbs up, thumbs down, swipe right, swipe left, swipe up and down. Let's say you as a beginner can go with these standard gestures, but assuming that you are an advanced developer, you might want to add your own gestures. So to do that, we also support for you to easily support addition of new gestures. We also have the gesture authoring tool, which helps you to add new gestures very quickly and easily. Next is the face and the face module. With respect to face, we do a face detection and tracking. With respect to face, we do a 78 landmark detection. Let's say landmarks would be something like a tip of your nose, or tip of your eye, tip of your mouth. Those are the landmarks that it detects on your face. And it also can do an emotion detection. Emotion could be related to a sad, angry, frustrated, confused. Those are some of the emotions that are supported. It can also do a face recognition. Based on the database that is already there in the system, it can recognize your face and match it to the face that is there in the database. You can also do a pulse estimation, meaning what is your pulse rate, heart rate, and all those things. With respect to speech, we use the standard Nuance speech engine, which can do a command and control, where you give a particular command and it takes an action based on the command. Some of the commands probably you might search Google for what the movies that are playing in Bangalore, or a command would be open up Explorer. You can also do a dictation mode where you just keep saying a particular paragraph and it keeps converting that tone to a text. You can also do a speech to text conversion for you. With respect to environment, it supports 3 things. It supports segmentation, 3D scanning, and augmented reality. What is segmentation? Meaning that, let's say you're sitting in front of the computer, it can segment out a piece of you and place it in a different environment. With respect to 3D scanning, it can scan a 3D object. The 3D object should be around 20 centimeters big. And let's say if the 3D RealSense camera scans the 3D object, and based on that, as a next step, probably you can do a 3D printing or post it to a particular website, or assuming it's a shopping website, right? It would be so cool to get a 3D image of a shoes or a jewelry or a dress and understand how does it look completely. That will enhance your shopping experience. Or it could be a augmented reality applications, where you can do a scene perception or a 2D and 3D object tracking. So let's understand our 3D camera in much more detail. The 3D camera, as I told you earlier, it sits on the top of on the bezel of the tablets or AIO or desktop machines or laptop machines. The range for the 3D camera is that it supports about 20 to 120 centimeters length. So whatever actions that you do within that range works perfectly fine. So beyond that, we don't guarantee the results. So that's the 3D camera specifications. The further slides. The 3D, if you look at the 3D camera, it's so small that it's as big as the $250 coin. So, and we are working with a couple of OEMs like Asus, Acer, NEC, Dell, to have them integrated into their OEM machines. So how does it work? If you look at that, right, there's the IR laser projector, which keeps projecting out laser lights, laser beams onto the from the device, from the camera, which has been captured from the color camera and LR camera. All the patterns that are captured is given to the USB 3 imaging async processing unit, where it converts these patterns into pixels, and it's passed on to the RealSense SDK and the operating system, and all the processing is done in the RealSense SDK. So We briefly touched upon the features of the SDK, what are the supporting features, and how does the camera look like. Let's understand some of the use cases of how this RealSense SDK can be used for your applications. We are giving at a high level what are the ideas that we thought might be used for this particular modules or RealSense SDK, but you as a developer can come up with different ideas or maybe a more innovative ideas using the RealSense SDK. So one of the first topic that Deepesh mentioned, the categories that Deepesh mentioned, so we'll dive into each of these topics and give a use case of how these RealSense SDK can be fitted into those categories. So let's, as a first category, let's look at immersive collaboration. So what is the in this particular application, in this particular image, right? Let's say you're segmenting out that particular user and augmenting that with a different background. Here, this particular lady might be had gone to a trip for cleaning a tower of pizza, and she's trying to explain to her friends how this what the description of cleaning tower pizza. So if you, with the gestures and with the background, augmenting it with a different background will add more immersive application. It will be easier for the user to understand. Or another example would be like, let's assume there are two people and they are doing dance class collaboration. So if they are in a, it feels that they are in the same room with both the persons doing the actions, and it's camera trying to capture those actions and augmenting that with a different background. Two persons can be sitting side by side and they can understand the movements. Another example would be that let's say this particular person who is supposed to be a coach is trying to explain to the kids who is sitting far away remotely about how the particular goal happened and what are the steps that he took to make this goal. So these are some of this. We're already working with a couple of ISVs like Microsoft, Skype, Microsoft Link, Skype to have immersive collaboration in their application. Second category would be to interact naturally. Based on the SDK features, you understood that we have a wide variety of gestures, facial recognition, speech recognition. So based on that algorithms, we can build a very innovative and intuitive application. Let's say this particular people are trying to cook something and they don't want to touch the screen with their dirty hands. So here they can just do a gestures or a voice command, and automatically the next recipe should come up, the next step in the recipe should come out. Or like there's a doctor who's doing a procedure, he wouldn't want to touch the screen, right? So yeah, automatically the screen should move based on the gesture that he performs. So these are some of the things, these are things that delight. There's another application that we have in open heart surgery sample, that application, that if the doctor wants to move the heart or kind of split, let's say he's cutting, he takes the application that we are working with ISVs, that he takes his finger and he draws a line from top to bottom. It feels that the heart is automatically breaking up. And these are some of the ideas that we can share. But it's up to you and how do you come up with the next big thing. With respect to gaming and play, there are a lot of ideas that can be done with respect to gaming and play. Let's say it can be as simple as a gesture. Let's say you're doing a fighting a first-person shooter game, right? And you want to do a shooting action, and you can do your fingers and you do a gun action, and automatically it starts firing up. Or you can do a head rotation. And the scene perception will happen. The scene will automatically keep changing, or you feel that the person is moving in the that particular place. Or it could be a particular command. Let's say you do a command, switch weapon, and a particular other weapon will launch. Or some of the applications is this in the left side. If you see the million minions, here is a simple application which we have demoed a couple of times. And if you Google it also, you can look for this particular sample. So here you are trying to crush the minions using your wrist. So as soon as you smash it down, the minions get crushed. Or it could be a Kung Fu Kevin application where you're trying to do a Kung Fu style of you're moving your hands and doing a Kung Fu action using your hands, and the application feels that you are doing a Taekwondo kind of action. So these are some of the possibilities, but that you can achieve using RealSense SDK. The another would be capture and share. So here in case of capture and share, I'm trying to capture a 3D object, and after I capture the 3D object, what I can do is I can give it to a 3D printer, and that 3D printer can take a picture of it and do the next step. Like maybe I can do a small object, to keep it in my decorative place, or I could upload it to a social media network, or I could make a keychain, something like that. So also imagine that it's a interior designing application, right? Before building up the whole house, I can do a 3D. I can print out a 3D image of that particular room or a particular house and visualize how the whole thing will turn out to be. So these are some of the ideas that you can do with respect to 3D scanning. With respect to education, the ideas are limitless. So here you can see that you can easily disguise learning as a play for the kids. If you make it more interesting for the kids, the retention power and the understanding is also much better. Here you can see that as soon as the kid moves the fire person, it turns off the fire. Or it could be as simple as a solar system where the kid automatically, as soon as he gets his hands closer, it zooms into a particular planet, and he can understand what are the different moons that are there around on that particular planet, or what are some details about those particular planets. We're working with Metaio here to track all the 3D and 2D objects and incorporate them into create a great learning experience for the kids. So let's now understand what are the supported features. So to develop this application, we require a minimum of Intel Core processor, Haswell and above, either IA32 or 64-bit OS. Currently, we support Windows 8.1 desktop, and Windows 8.1 Metro is support coming up shortly. The programming languages we support are C, C++, JavaScript, Java, and the IDE is Visual Studio 2010 and above, and Eclipse. The supported language development tools that we support is .NET Framework 4.0 and above, Unity Pro. Keep in mind we need a Pro license to support Unity. Processing, Open Frameworks, Havoc, and Intel Media SDK, the Intel SDK for OpenCL. What are the additional SDK features? You can have multiple applications access the data from the camera stream, the stream of data that's coming from the camera. You can have multiple applications accessing the same data, or it can have a multi-mode support where the same application is having multiple modules of the same as RealSense SDK. It can be a finger tracking plus speech plus face tracking applications. Although the power management is quite good. It doesn't consume so much of battery life, and you can have a longer battery life for your tablets and laptops. The SDK is very extensible framework. The developers can usually plug in their own algorithm, and new usage models or new devices can be added easily. Also, there's a privacy notification tool which pops up as soon as you launch the camera. So this lets the user know that the data from the camera is being accessed across the network or across the application. So we also have added support for web and HTML5. We also support the Unity player for Unity web player games. So how does it work is we have there are a couple of samples in the SDK as well to understand this. So it launches you launch the application with the internet browser, which is a JavaScript enabled or Unity web player enabled app, and it does a WebSocket communication with the SDK, which is a local web SDK, which in turn interacts with the RealSense SDK runtime, which communicates to the operating system. Currently, we have support only for gestures and facial analysis. With respect, we also have support for Unity. With respect to Unity, it's a set of scripts that provide actionable rules based on the capabilities provided in the SDK. So how do we do that? Using Unity Pro Edition, we create an object for each of the different modules that we want. Let's say you create a cube as an object and associated all the game objects with the rules for that, meaning that this particular object will have gesture support, will do all the facial tracking and finger tracking for that particular object. And it's very easy. It's a drag and drop programming. You don't need to write much code, and it's quite easy to use also. With this, I will pass it on to Deepesh, who's going to talk to you about the SDK developer programs and how you can participate in the RealSense challenge. Thank you.
Thank you, Shweta. Thank you for the wonderful details about the SDK and the camera technology. With this, let's just advance this journey further.